This mini lesson will go through the steps of solving or subtracting polynomials. So if we look at the first polynomial or set of polynomials, we have 4p squared or 4p to the second power minus p minus 3 subtracting p squared plus 2p minus 5. So what we have to do here in our second parentheses is we have to multiply all of the terms p squared or p to the second power or p raised to the power of 2 plus 2p minus 5. They're all going to be multiplied by 1, or should I say they're all going to be multiplied by negative 1. So each term in the second parentheses is going to be multiplied times a negative 1 first. So we have to do that first before we actually go through the process of subtracting these polynomials. So we're multiplying each term inside of the parentheses times negative 1. You may recall that it's called distributing. We're using the distributive property. So once we multiply negative 1 times a positive, any one of those numbers is positive, it's going to change to negative. Any one of those numbers or terms that is negative are going to change to positive. All right, let's do that now. So negative 1 times p squared becomes a positive p squared. Negative 1 times 2p, positive 2p now becomes a negative 2p. And negative 1 times a negative 5 becomes a positive 5, okay? So the next step is we have to realize that that minus sign that was on the outside of the two parentheses now changes to a plus sign. So to eliminate the confusion, I'm going to erase this plus sign here just in case we have any confusion. And we're going to use that plus sign that I just erased to put it in place of that minus sign that used to be there before we distributed that negative 1. So now it's plus here. The first set of polynomials will stay the same. Do not change. Do not change them. They stay the same. So now we can go through the process of ordering these into a vertical form so we can see which terms that we can combine. And this makes it more simple. It mitigates or it lessens the chance of you making mistakes. So let's do that now. So we have 4p. We actually have 4p to the power of 2 or raised to the power of 2. We also call that 4p squared. 4p to the power of 2 minus p minus 3. I'm going to put a plus sign out here. And then I'm going to bring the p squared from the second parentheses, and I'm going to line it up with like terms. So what other term has a p squared in this subtracting polynomials? What other term? If you said 4p squared, you would be correct. So that p squared needs to be added to the 4p squared. Okay, so let's bring that over. So p squared goes with 4p squared. And by the way, that is 1p squared. I know there's no number in front of the p, so it's assumed to be a 1. Okay, so now we have the next term for minus p or minus 1p. What term is like minus 1p? If you said negative 2p or minus 2p, you would be correct. So we'll line that up vertically, negative 2p. And then for our constant, we have a minus 3. What term is like the minus 3? If you said the plus 5, you would be correct. Now we have what we need to subtract our polynomials. All right, so what we have here, 4p squared plus 1p squared. 4p plus 1p. Well, 4p plus 1p is, or should I say, 4p to the second power plus 1p to the second power is 5p to the second power. And let me change my p. Let me change my square to make it more of a 2. And then we have a negative p minus 2p, or negative p plus a minus 2p. Well, that will give us a negative 3p to the first power, by the way. And a negative 3 plus 5. That's going to give us a plus 2. So what we have here is 5p to the second power minus 3p to the first power plus 2. This is our final answer. There's nothing else that we can combine together for this to be correct. Okay, let's go to the next one. Let's try another example. I'll move this a little bit to the center here, and let's do it. This might look kind of familiar to you, though. See if you can spot what is different. We have 4p to the second power minus p minus 3, and it's going to subtract a negative p squared plus 2p to the first power minus 5. Looks familiar? It should look familiar because this time we have a minus or a negative p squared here. So once again, just like in the first example, everything inside, or all of the terms inside the second parentheses, has to be multiplied times a negative 1 first. So we're going to multiply each term times a negative 1, and then we'll go through the process of lining these up vertically, lining up the terms vertically. So negative 1 times a negative p squared is a positive p squared. A negative 1 times a positive 2p, or 2p to the first power. Negative 1 times a negative 1 times a positive 2p to the first power, negative 2p to the first power. And a negative 1 times a negative 5 gives you a positive 5. As before, that negative or that minus sign that was in between the two parentheses now changes to a plus sign. So now it is plus. After you use the distributive property, you change that negative sign to a plus sign. And the first terms, or the first set of terms, stays the same before we line these up vertically. Okay? All right, next step, we're going to line up our terms that are alike so we can mitigate or lessen the chances of making mistakes. We put the plus sign on the outside. We'll bring p squared. We're going to add it to the 4p squared. We're going to bring the negative 2p. We're going to subtract it from the negative 1p. And we're going to bring the plus 5. We're going to add it, we're going to add it to the negative 3 here. Okay. All right, we have, we'll go from left to right this time. 4p squared plus p squared. So that's 4p plus 1p, so 4p squared plus 1p squared. Remember, you do not add the exponents, so it should not be some number to the fourth power. It actually is going to be, you add your two coefficients together, there's a 1 in front of that p squared that's below the 4p squared. So this becomes 5p, this becomes 5p squared. Then we have a negative p plus a negative 2p, which is going to give us a negative 3p to the first power. Don't forget that this is to the first power, even though it doesn't have an exponent. And then a negative 3 plus 5, well, that's going to be a positive 2. So we cannot combine anything else here, meaning we can't add or subtract any other terms together. So this is the final answer here. 5p squared minus 3p to the first power plus 2. Okay, let's try the next one. And this one, I want you to actually try it out first, pause the video, and then come back and see if you have the correct answer. All right, so what we have here, we have 3m, or 3m to the first power plus 4m to the second power minus 7, and we are subtracting negative 5m to the first power plus 7m to the third power minus 2m to the second power minus 12. Close parentheses. So check, work this one out first, pause the video, work it out first, and then come back and see if you had it correct. So of course I know that you paused the video and you worked it out on your own to see if you had it correct. And let's see if you did or not. Well, let's check and see. So remember to first distribute a -1 to all of the terms in the second parentheses. That means multiply each one of those terms times a -1. That's the first thing you should have done. So when you multiply a negative times a negative, of course, we should know that it changes to a positive. So this becomes a positive 5m to the first power. A negative times a positive is a negative. So we get a 7m to the third power. Negative times a negative is positive. So we get a positive 2m to the second power. And a negative times a negative is going to give us a positive again. So we'll get plus 12. We can close the parentheses. We can leave it as this is, as it is right now. We don't have to put a parentheses around these two. And I won't. And I'll just leave it like this. But we'll combine the terms. Next, 3m to the first power plus 4m to the second power minus 7. Remember that the first set of terms, they stay the same. And now the next step is we can go ahead and put these in vertical order. We're only going to put the terms, or put the terms above or below each other that are alike. So we have 3m, I'll change the color, 3m to the first power. Well, what term is like the 3m to the first power? If you said the 5m to the first power, you are correct. So then we have 4m to the second power raised to the second power minus 7. And what term is like the 4m to the second power? If you said the 2m to the second power, you are correct. And we have a minus 7 here. What term is like the constant? Constant are the numbers without variables next to them. What term is like the constant minus 7? If you said plus 12, it's the only other term that doesn't have a variable next to it, then that would be correct. Now we have one additional term here, which is the 7m to the third power. There is no other numbers or no other terms that have m to the third power, so he's all by itself. So we can either add 0 to it, or we can just leave it there. And I'll just add 0 to it. And of course we know the identity property of addition. When we add 0 to a number, we get the same number. All right, so let's do it now. So we have 3m plus 5m. Well, what's 3m plus 5m? If you said 8m to the first power, you'll be correct. Then we have 4m to the second power and 2m to the second power. If you said 6m to the second power, you will be correct. And negative 7 plus 5, that will give us, negative 7 plus 12 will give us plus 5. And then 0 plus a negative 7m will negative 7m to the third power. Correction. That will give us a negative 7m to the third power. Now, this is the final answer here. And I'm going to take one extra step and just put these in order by their exponent, by their powers, their exponents, the power of the exponents here. So I'm going to order these from least to greatest by their exponents, and they're called degrees, and you'll learn that later on in lessons that I post, or you can look it up on your own. But let's do it now. So we have a negative 7m cubed, or negative 7m to the third power. This is our first one if we're ordering this from greatest to least, actually, based on the exponent. So negative 7m to the third power plus 6m to the second power plus 8m plus 5. Now remember that these expressions are the same. They just have been moved around. This is the final answer. And this is subtracting polynomials in a mini lesson. So I would love for you to put comments in, put